Well, hello, welcome back. Yeah, I found this problem. I was just talking about last video was something like this. I got these three intersecting circles here. R equals 2 here is centered at the origin. R equals 4 cos theta sits over there. R equals 4 sine theta sits there. And it gets confusing looking. And anyway, I want the area inside 4 sine theta. So inside of the 4 sine theta, but outside the 4 cos theta and outside the R equals 2. So not in there and not in here, just in the 4 sine theta, but outside 4 cos theta and outside R equals 2. So there it is. That's the area I want. And I think that's going to be a little tricky, man. And I think what I really need is I need these points of intersection. Like I want to know where I need this one. I definitely need to know what that is. And, we can do it. It's when R equals 2 equals 4 sine theta. I think I did this in another video. When you divide, that's a half, and this is pi over 6. 30 degrees, that's very famous. This one over here is 30 degrees in quadrant 2, so this is 5 pi over 6. So that's good to know, man. It's good to find, that's what you need. And so where's the other one? Oh, that's this one, pi over 6. All right, I don't really need that other one, that pi over 6. I might need this guy. When does 4 cos theta equal this 4 sine theta? Oh, which is also, oh no, I'm getting confused. Look at this, I might need this guy. When does 4 cos theta equal 4 sine theta? That's this one. Now look at that picture, dude. It's right in the middle, it's right in the middle. You want to guess? You can do the math. When does 4 cos theta equal 4 sine theta? You can divide by 4, that won't matter. When does cosine equal sine? When does cosine equal sine? It's 45 degrees. It's 45 degrees, pi over 4. So that's that place. Now, I think I need this place. Now, what the hell is this? This is when the 4 cos theta intersects the R equals 2. When the 4 cos theta hits the R equals 2. Divide by 2 cosine theta. That's when cosine theta is a half. Sine theta is a half at 30 degrees. This is 60 degrees. So, oh yeah, okay, so this is pi over 3. These are all a bunch of famous angles, dude. This is pi over 6. This is pi over 3 right here. Wow. All right, a good picture, a blown up picture. I'm working a little small here. You guys got plenty of paper, waste plenty, get a good looking big picture, nice circles, nice lines, and you'll see it all much clearer. Don't try to work off that little calculator screen. The calculator helps you see what's up, but then you need to blow it up. Yeah, I mean, I think I can get a big chunk of this. I can sweep out sectors of area from the pole. I can go out here and get all this area, and I think I can do that from pi over 3 to 5 pi over 6. I mean, that's awesome. I'll go out here, I'll get this area. But I will have to do my outer function minus my inner function. But I think I can go from pi over 3 to 5, let me set this up, pi over 3 to 5 pi over 6, 1/2 out front, and I want the outer function squared, 4 sine theta squared, minus the inner function, which is this R equals 2, this 2 squared. That's how you subtract out area. My sector went over that area that I didn't want, so I'm subtracting that out. From pi over 3 to 5 pi over 6. So that gives me a big chunk of this. Now, I really should zoom this in because there's some I haven't got yet. There's this little bit of area right here. I need to get that. Well, I could probably go from pi over 4 to pi over 3, so I need to add to this. Probably should go from pi over 4 to pi over 3. What am I going to do? Go out there and hit this function, 4 sine theta? Yeah, that's what that is. That's 4 sine theta out there. From pi over 4 to pi over 3. I'm going to hit 4 sine theta squared, but I think there's some stuff I don't want. When I sweep out a sector, I get all this stuff here I don't want. So who am I subtracting out? And I think I'm subtracting out this curve, which is the 4 cos theta, right in there. That's who I'm subtracting out. I'm subtracting out the 4 cos theta squared. Wow. Put a half in front of it. This is the formula. Hey, I think we just figured this out. This would be a great problem to say, set up the integration. Because we did. We set up the integration to find that area. But we didn't do the integration. Does anybody want to do the integration? Should maybe hit pause and digest this setup. We got it set up. I like getting it set up. I also like integrating, but that takes a lot of work. It takes a lot of work, I think. I'll race you. On your mark, get set, go. If I square that, it's 16 sine squared theta minus 4. There's a half out front, and I'm trying to integrate. The half angle formula tells me, I think I'll put this half in here. That'll make it an 8 sine squared theta minus a 2. Anyway, now the half angle formula tells me this is a 1/2 1 minus cos 2 theta multiplied by this 8, so that's a 4. I think I'll go ahead and integrate. Now, I'm sorry, got a little sloppy here. I think I'll integrate the 1. That's a theta. And a 1/2 sine 2 theta. And I think I'll integrate this 2. I think that'll be a 2 theta. I think I'll combine a couple like terms. That's a 4 theta minus a 2 theta. That's a 2 theta. This 4 distributes, makes this a 2 sine 2 theta. I think I cleaned up this answer, believe it or not. Believe it or not. What are my bounds? Pi over 3 to 5 pi over 6. 5 pi over 6 to pi over 3. All right, that gets a little tricky. Plug that in, 2. I mean, that's tricky, man. 5 pi over 6 minus 2 times the sine of 2 times 5 pi over 6, which is actually 5 pi over 3. Minus, you plug in the pi over 3, that's 2 pi over 3, minus 2 times the sine of 2 pi over 3. All right, I know those answers, I think. So what's that? That 2 cancels. That's a 5 pi over 3 minus, so the sine of 5 pi over 3, I draw a little unit circle, 5 pi over 3. That's all the way over here. That's 60 degrees over here. That's square root of 3 over 2. But the sign is negative over there. The sign is negative over there. Sine is negative square root of 3 over 2. So that's a 2 times a negative square root of 3 over 2. I'll clean that up. Minus, be careful, that's a 2 pi over 3. And that is the sine of 2 pi over 3. That's over here, 2 pi over 3. That's 60 degrees. That's a square root of 3 over 2. Sine is positive there, square root of 3 over 2. This is awesome. Here we go. This is a 5 pi over 3. What is this? Plus a square root of 3. The 2's cancel. Minus 2 pi over 3. And plus another square root of 3. Hey, that's pretty cool. The 5 pi minus the 2 pi over 3 is 3 pi over 3, or just pi. This answer is pi plus 2 times the square root of 3. Now that was the answer to this. I still got to do that. I want to show you a trick. Here comes a trick. I'm sorry. I think I did that. I hope I did that right. I did it as fast as I could. Getting rid of it though. Sorry. I should have warned you. Hit pause. I'm erasing it. I want to try this integral. When I square that, it's 16 sine squared theta minus 16 cos squared theta. right? With a half out front. So actually I'll pull the 16s out. That'll be an 8 out front. And then I'm sitting there with a sine squared minus a cosine squared. So a sine squared minus a cosine squared is not the famous sine squared plus cosine squared, which is 1. And to tell you the truth, it's the opposite of the famous cos squared minus sine squared is actually the cos of 2 theta. But this is sine squared minus cos squared, so I think it's the negative cos of 2 theta. Damn, I hope I'm right on that. Cos squared minus sine squared is cos 2 theta. That's a double angle identity. And if that subtraction is backwards, this is negative cos 2 theta. I think I am right about that. Dude, this is easy to integrate. How do you integrate a cos 2 theta? By the way, you know what you could do? A couple half angle formulas cleaned up would be this. A couple half angle formulas, clean it all up, would turn into this. So I got there quicker. Anyway, you integrate a cosine, you get a sine 2 theta. It spits out a 1/2. It hits this negative and this, so there's a negative 4 out front. You're evaluating from pi over 4 to pi over 3. We're almost done. We plug in the pi over 3, we get negative 4 times the sine of 2 pi over 3. I know what that is. Minus negative 4 times the sine of pi over 4. I mean 2 pi over 4, sorry. 2 pi over 4. Okay, I know what this is. That's negative 4, and that's 60 degrees in quadrant 2. That's a square root of 3 over 2. That's a positive 4, and the sine of pi over 2 is a 1. So that is negative 2 square roots of 3 plus 4. That's that answer, which is a positive answer. It should come out positive. We set these things up to be area. Cool, that's my positive answer. Hey, I'm going to take that answer, add it to this answer, which is pi plus 2 square roots of 3, and that's pretty interesting. The 2 square roots of 3's cancel. My final answer is pi plus 4. That was the area of that cool shape we had up there a minute ago. Wow, this is fun. You got to admit it. You got to love it, you guys. Love it. Do it. Learn it. Love it.